Okay, good evening. This is Professor David J. Delos Okay, my topic for tonight will be a continuation of my subject matter, trigonometry, and we are now on lesson number 3. I am now on lesson number 3. For those of you who are following my channel, we are now on lesson 33. The subject matter is actually trigonometry, long video format. So this is for those who would like to take up engineering maybe. This is for you guys. Okay, let's proceed. The subject matter for tonight will be trigonometry, a continuation of my long video format discussion on trigonometry. And we are now on lesson number 33. It is getting interested because the subject matter is actually regarding identities. And the title of the topic for tonight will be Example Problem on Sine of a Double Angle. The last time around, I derived the identities on the sine of a double angle or a cosine of a double angle. So to illustrate that concept, I will be presenting an example problem on the sine of a double angle. Sine of twice alpha. Okay. The variation of the problem falls under the so-called sine of double angle, meaning we got an angle and it is twice. That's why it's double angle. Okay. So at least we could visualize the importance of the expansion of the sine of a double angle. What we are solving for tonight will be a trigonometric equation. Okay, there is an unknown angle x. Okay, and we are asked to solve for that value of x. Just like in the study of algebra, if we are given an algebraic equation, we are asked to solve for the value of x. Okay, emanating from that given algebraic equation. But for tonight, what is given is actually a trigonometric equation. So it's a little bit harder because what we have studied under the concepts of algebra, okay, we will still apply it here, but there is another problem because the problem is not simply algebraic, it is trigonometric. So at least you know something about trigonometry, much especially on the so-called identities. Okay, let's proceed. The example problem is just a simple one. And this could come out from the short videos on what you call this YouTube maybe, but it seems what they are solving is just the simple ones. It's not the long solution because we are only given 60 seconds maximum of the short video. That's why I prepare to bring out this problem here on the long video format. Okay, I will try to read the problem. The given trigonometric equation is the sine of the quantity x plus 45 degrees multiplied by the cosine of the quantity x plus 45 degrees, and it is equal to 1/2. And we are asked to find for the value of x. Meaning, try to solve for the value of x, and later on try to substitute that value of x here. And try to compare the value of the left hand side with respect to the right hand side. If they are equal, your solution is correct. Because that's the proper procedure on how to verify the validity of answer. So what is given here is sine of the quantity x plus 45 times the cosine of x plus 45, and they should be equal to 45. The problem is asking what will be the value of x. So what is given is a trigonometric equation. Okay, it's trigonometric, it's not algebraic. Algebraic is just a pure x without the trigo function, but in here we got the trigo function, sine and cosine. So this should fall under the so-called trigonometric equation. Okay, let's try to bring out the solution. There are two solutions on this one. what I presented on the first solution is actually the solution for tonight. Maybe the next time around, I will present another solution, okay? And the solution for the next solution will be another variation on the solution of this one. Because there could be 2 possible solutions or 3 possible solutions, but in here, I brought out already the second solution, and it come out that the solution is still x equal to 30 degrees. So the next time around, I might bring out the second solution just to verify that our answer for tonight is correct. Okay, so let's try to concentrate on the solution for tonight. I think this solution is just the smartest solution possible for the time being. Okay, let's try to bring out the solution. We let the value x plus 45 degrees to be equal to angle alpha. Because it seems we are given angle A here. And no, angle A is unknown, and the second angle is B. So it seems we are on the so-called expansion of sine of the sum of 2 angles. But what I will be presenting for tonight is not that solution. It will be by using the so-called sine of a double angle. I think it is just a simpler solution, but it's easy to comprehend. Okay, let's try to bring out the solution. We let alpha equal to the quantity x plus 45 degrees. Okay. Let's try to recall the formula and how to bring out the relation of a single angle in terms of a double angle. The last time around, I brought out how we derive this one. Right? Sine of twice any angle, it could be alpha, it could be beta, it could be gamma, is equal to twice the sine of that alpha times cosine of that alpha. Okay, we brought out this one the last time around. Actually, I derived this one. One of the formulas under double angle of sine double angle is actually sine of twice alpha is 2 sine of alpha cosine of alpha. If we try to inspect the right hand side, this portion here, right, is similar to the given problem, right? So it seems this is now, because we represent this one as alpha, and this is also as alpha. So it seems this is sine of alpha, cosine of alpha, it is this. Okay? So to bring out the solution in terms of a double angle, okay, we will take the equivalent of this in terms of a double angle. It is actually given now. Okay? Because if we try to compute for the product of sine of alpha, cosine of alpha, okay, we eliminate these two here. Okay, so the product of sine alpha, cosine of alpha will be 1/2 of sine of twice alpha. It is this. 1/2 sine of twice alpha. So instead of using the single equivalent, we will be using twice alpha. That's why our topic for tonight is a solution example problem on the sine of a double angle. Okay? Oh, let's try to substitute. We'll follow this. 1/2 sine. Okay? There is 2 here, right? So this is 2. Our alpha is actually x plus 45 degrees. This is our alpha. Okay? This is open bracket, close bracket. Meaning, the total angle of the sine function is twice alpha. This 2 here is inside. It is not before the sine value. So this 2 here should be multiplied to the total angle inside. Okay, what will come out? Okay, let's do like this. We multiplied this by 1/2, right? So these 2 here cancel with this. The left hand side will now be sine. We'll try to distribute this one. This 2 here is a multiplier of the total angle inside, right? So we could actually distribute it. Okay? It is not before the sine value. So 2 times x will be 2x. And 2 times 45 is 90 degrees. Close quantity is equal to 1/4 times 1/2, okay? 1/4 times, is it 1/2? Oh, this should be 2. Sorry for this one. The multiplier should be 2. Because 1/2 times 2 is actually, this 2 here cancel with this. And 1/4 times 2, this should be equal to 1/2. And 1/2 is actually this one. So after expanding or distributing the total angle on the left hand side, which is 2x plus 90 degrees, and this should be equal to 1/2. This is now our resulting equation, right? It's the sine of the quantity 2x plus 90 degrees closed quantity, and this should be equal to 1/2. Okay. We are asked to compute for the value of x without the sine function. So we must have to eliminate this sine function here. So to eliminate the sine, we will take the arc sine of both sides. The arc sine of the left hand side, which is sine of the quantity 2x plus 90 degrees, equal to the arc sine of 1/2. Whatever we do on the left, do it on the right. Okay. And for the left hand side, the arc sine of the sine of any given function is just the given function. Actually, this cancels, right? So what remains on the left will be a 2x plus 90 degrees. And this should be equal to the arc sine of 1/2. You can use your calculator here, but sine of 1/2 is actually a spatial angle. What angle in which, if we try to take the sine value, it is 1/2. The angle is actually 30 degrees. Right? Spatial angle. This is 30, this is 1, 2. Sine of 30 is actually 1/2. So it seems here, if you try to punch 0.25 in your calculator, in your press arc sine, what will come out here is 30 degrees. Like what I said, 1/2 is a spatial value. So I know for a fact that the arc sine of 1/2 is 30 degrees. So this is 30 degrees. So either you would use your mind, or use your calculator, or use your trigonometric table. So 2x plus 90 degrees is equal to 30 degrees. So this is now our resulting equation. It seems this is now an algebraic equation. The unknown just contains x without any sine or cosine function. That's why it is now an algebraic equation. And to solve an algebraic equation, we done that under the study of algebra. Okay, try to maintain the unknown on the left and transpose all constant terms to the right to compute for the unknown. So 2x should be equal to 30 degrees. We transpose this to the right, minus 90 degrees. So 2x will be negative 60 degrees. And to compute for x without the value 2, we must have to multiply this one here by 1/2. So 2 times 1/2, this will cancel out. X now. Okay, the right hand side will be 1/2 times minus 60. And this is 1/2 times minus 60. And the value of x is actually negative 30 degrees. Okay, that's our answer. And to check the validity of this, we'll try to substitute this x here back here. And try to compare the value of the left hand side and the right hand side. Will it be an equality? Okay, let's try to substitute. If x is negative 30 degrees, this will become 15 degrees. And this will become 15 degrees. So what we are solving from the given equation is sine of 15 degrees times the cosine of 15 degrees. Will it be equal to 0.25? Sine of 15 degrees, it's a small value, 0.259. Cosine of 15 degrees, it's almost zero, it's almost unity. This is times 0.965. We multiply this one, will it be equal to 0.25? 0.259 times 0.965, if you try to use your calculator, this is exactly 0.25. And since this is 0.25, and the right hand side is 0.25, we now try to remove the question mark, and we will place 0.25 is really equal to 0.25, it is true. So our answer is actually correct. Okay, that's it guys. That's how we compute for the value of x by using the expansion of the sine of a double angle. Okay, so the next time around, I will bring out the second solution by using another solution, not same as this one, but it should be the expansion of the sum of two angles. Okay, good evening from Los Angeles, Professor David J. DelosReyes.